Hello everyone, this is our session 4 on application of derivatives. We finished with exercise 2.1. Okay, now moving to the next topic. I have informed you previously that some parts of this chapter are not included in your syllabus, in your revised syllabus. I'll repeat it once again. I'll just show you the textbook. Okay. Yeah, so if you can observe here, we have 2.3.1, sorry, even before that, approximations is excluded, 2.2.1. Okay, then Rolle's theorem is excluded, and we have Lagrange's mean value theorem, which is excluded. Okay, you can still go through it once, and if you have any doubts regarding it for your other studies, you can definitely ask me regarding it. We're starting now with increasing and decreasing functions. Okay, so yes, so if you can read here, increasing and decreasing functions, what does it mean? We've it's simple that increasing functions, if you can see the graph 2.4.1 that is there in the figure. Okay, so it's an increasing graph, right, from the interval a up to the interval b. A function f is said to be a monotonically or strictly increasing function on any interval a comma b. Okay, if for any x1 x2 x2 are these values on the x-axis belonging to a comma b, with if x1 is less than x2, very important, x1 is less than x2, then we have f of x1, that is y value of x1 and y value of x2, they are less than each other, that is x1 is less than x2, so f of x1 is less than f of x2. We are considering an increasing function here, y equal to f of x in a comma b. Now let h greater than 0 be a small increment in x, then, okay, so if h is a small increment, that is a small change in x, that is from x1 to x2, there is a lot of values you can see, right? So we're taking a very small change between them also. So we know that x is less than x plus h. Is that true? Yes. So x will, let's say, come somewhere here, okay, before x1 or after x1, and x plus h will be after that, right, lying between x1 and x2. Now here they've said let x equal to x1 and let x plus h equal to x2. So basically now they're calling this as x and this is x plus h. Okay, x2 as x plus h. What is h? A small increment in x. Now since we have said that y is an increasing function of x, when you say that, it means that values of y are increasing this way exponentially. Okay, so if it is an increasing function of x, then what can we say about f of x1? Okay, so f of x1 will be less than f of x2. Okay, what is x1? It is x, so f of x is less than f of x plus h. Okay, therefore we have that x plus h function will always be greater than f of x. Subtract, take left f of x on the left side. So we get f of x plus h minus f of x is greater than 0. Okay, now I'm dividing that by the small change h. Okay, and I'm applying limits, or you can say dividing both sides by h and then applying limits on both sides. What do we get? Limit h tending to 0, f of x plus h minus f of x upon h is greater than or equal to 0. So you're either going to get 0 or greater than equal to 0. What is this now? The basic definition of derivatives, f dash of x. So what do you understand by this? That and for any increasing function, whether you have to prove it as an increasing function or verify whether it's an increasing function, the derivative of that function, f dash of x, should be greater than or equal to 0. Clear? So if this is the case for increasing, then what it would be for decreasing now? So decreasing function, there is a small printing mistake in the textbook. Okay, so I'm just decreasing function, I'm just showing it to you. A function f is said to be monotonically strictly decreasing function on an interval a comma b if for any x1, x2 lying between a and b, x1 is less than x2 and f of x1 is greater than x2. Can you observe that? So x1, yes, it is less than x2. It's going on the positive x-axis this way. So x1 is less than x2. But can you observe f of x1? What is its y value? It's somewhere here. And what about f of x2? It's somewhere below. That means it has dropped down, right? So we know f of x1 is less than f of x2 when x1 is f of x1 is greater than f of x2 when x1 is less than x2. Okay, that means lower value of x1, higher value of y1, higher value of x2, lower value of y2. Okay, so considering a decreasing function, that is exponentially decreasing function, okay, y is equal to f of x in a comma b. Let h be a small increment in x. So again, we'll follow the same method and you get f of x plus h greater than x. X plus h greater than x. F of x will be greater than f of x plus h. This is what I was saying is a printing mistake. It should be greater. That means even if I'm adding a small value to x, the function f of x plus h, okay, will be less than f of x. Okay, that is what you understand by decreasing function. Though the value of x is increasing, the value of y is decreasing. Okay, so in the end, you come down to the same thing, limit h tending to 0, f of x plus h minus f of x upon h, but it says less than equal to 0. That means derivative of that function should be less than or equal to 0, then we can call it as a decreasing function. Let us take an example to understand the same. Okay. Okay. So the example that I'm taking to understand what is increasing and decreasing function. So f of x is equal to x cubed plus 10x plus 7. Okay. Now differentiate this function. Differentiate with respect to x. So f dash of x will be what? It will be equal to 3x square plus 10. Now we have to find out whether f dash of x is greater than 0 or it is f dash of x is less than 0. Okay, now observe what is f dash of x. It is 3x square plus 10. Okay, let's break this as 3x square will always be greater than 0 for any value of x. Is that correct? Any value of x belonging to real numbers, right? So any value of x, let's say I take 1, it will be 3, 2, it will be more than that, right? So it's always going to be greater than 0. Then what about this part, plus 10? Of course, 10 is already greater than 0 that we can see. So when I add these two values, that is 3x square plus 10, that will also be greater than 0, right? That means my derivative value f dash of x for any value of x is always going to be greater than 0, correct? So we can say that f dash of x is an increasing function. Clear? This is an example for increasing function.
Okay, so we've completed what do we understand by increasing functions and decreasing functions. Okay, so what do we know about increasing functions? F dash of x should be greater than 0. Okay, so if I say that f of x is an increasing function, y equal to f of x is an increasing function, means what? Or you can say monotonically increasing function. Okay, now what does that mean? Monotonically increasing function. So it continuously increases, increasing function. Okay, if f dash of x is greater than 0. Okay, and y equal to f of x is a decreasing function, right? When f dash of x is less than 0. Okay, so if you notice, we had done the graphs also for the same. So f dash of x is greater to 0. So this is the graph, and here this stands as the graph. So it's monotonically increasing graph. As the values of x increase, the value of y increases. Here, as the value of x increases, the value of y goes on decreasing. Okay, that is y equal to f of x decreases. So any values that I choose for x, okay, or you can say if I have to choose between x1 and x2 small intervals, here also x1 and x2 small intervals, okay, then f of x1 is less than f of x2 in this case, right? So second function is greater than the first. Here, when I choose x1 and x2, the first function is greater than the second. So that is why it is called as a decreasing function. Always remember the graph, how it flows. I have a particular value of x that is going on increasing, but my value of y goes on decreasing, right? So whenever I go on increasing this x over here, if the answer of y goes on decreasing, then it is called as a decreasing function. And increasing, as I increase the value of x, it will increase the value of y also. Then it is called as a increasing function. Now that I understand from the graph, how do I use derivatives for the same? So I'll differentiate the function, okay? And if it comes greater to 0, then it is increasing function. If it comes lesser than 0, that is differential of that function comes less than 0, then it is a decreasing function. Okay, this is what we did with an example in the previous part. Now I'm moving to another part of increasing and decreasing functions. It's called maxima and minima. Okay, so let me write that for you. So what do we understand by these two words, maxima and minima? It says maximum point a function reaches and minimum point a function reaches. Okay, so that is maxima and minima. Let's begin with maxima. Okay, so what do we understand by maxima now? For x equal to c, okay, for x equal to c, the value of x is greater, okay, than any other value of f of x, okay, in the neighborhood of c. Okay, now let's try to understand this. For x equal to c, the value of f of x is greater, okay, in the neighborhood of c than any other value of f of x in the neighborhood of c. Okay, so now let me explain to you what this sentence means using a graph. Okay, so sorry. Yeah, let's say we have an xy axis, okay, and bigger axis over here, okay. Yeah, now for x equal to c, the value of f of x, okay, so this is y equal to f of x over here, yes, and this is your x values, okay. Value of f of x is greater than any other value of f of x in the neighborhood of c. Okay, so let us say that this is x1, this is x2, and here is where c comes, okay. Now x1, x2 and c, all these are very small values, okay. But when do I say that it is the maxima of the function? When I find out the value of f of x at x1, that is f of x1 I'll find out. I'll find out f of x2 and I will find out f of c. Okay, so yes, right. So when I find out f of c, what I'm supposed to be getting in the graph, right? That means this point here should act as the maximum point y equal to f of c. Okay, it will act as the maximum point if any value less than c and any value greater than c are not, or you can say are lesser than f of c. Okay, so in a small interval x1 to x2, c lies between that interval. If f of c is the maximum, okay, then it is called as the maxima point. Okay, now let us understand how do we explain this using functions. Okay, so I'll write it as c minus delta less than x less than c and c less than x less than c plus delta. Okay, now okay, so yeah, c minus delta less than x less than c and c less than x less than c plus delta. This is what from our graph, if you observe, it is this part. Okay, x1 can be called as c minus delta, okay, small interval, and x2 can be called as c plus delta, small change in value of x. Okay, so now what can we say about the left hand side function? That is, when x lies between these two values x1 and x2, sorry, c, when x lies between x1 and c, what can we say about this function? See, what do you observe? As value of x1 is changing, y is increasing, right? We just did something called as increasing functions, right? As x is changing, y is increasing. Can you see that? Similar kind of function. So what can I write over here? I can say that this is supposed to be increasing. Okay. And what about the second interval? That is on the right side, c less than x less than c plus delta. What about this interval? As the value of x is increasing, what is happening to the value of y? It is dropping down, right? So what will we call that as? We will call it as a decreasing function. Okay, so when I want c to be maximum, when I want the maxima point, what is the condition it should satisfy? All the values less than c should act as increasing function. All the values greater than c should act as decreasing function. Okay, so that then we can say that f of x has its maxima at c. Okay, once more I'll repeat it. All the values below c, okay, less than c in a small interval x1 to x2. Okay, so from x1 to c it should act as an increasing function. Okay, so let's say x1 is c minus delta, so c minus delta less than x less than c. Okay, that's here, should act as an increasing function, and then ahead of c, that is c less than x less than c plus delta, should act as a decreasing function. Then f of x has its maxima at point c. Okay, now if this is the case with maxima, then what can we say about minima? Okay, just a minute. So if that was our maxima, what can we say about now minima? So let's write that. What can we say about minima for x equal to c? The value of f of x, okay, should be smaller than any other value of f of x in a small neighborhood of C. Clear? So exactly opposite to maxima we can say. For x equal to C, value of x should be smaller than any other value of f of x in a small neighborhood of C. Let's put it down in the form of, you can say graph. So if you have your x-axis here and your y-axis here, okay, and then we label this as y equal to f of x for us, right? And these are the values of x. Somewhere here, let's say we have c, okay, here we can have c minus delta, small change, and c plus delta. Okay, you can call them x1, x2 also, a, b also, any small change in c basically. Okay, now what does it say? For x equal to c, the value of x should be smaller than any other value of f of x, right? In a small neighborhood of c. So in a small neighborhood of c means what? So let us plot it. It would be, okay, this is a little wavy curve. Okay, somewhat like this. Just put it again. Yeah. So now what does this graph mean? Okay, at C, it goes to its minimum value. Okay, after that, if you observe, if you plot, what will you see? You will have the values on the right side increasing, right? Over here, we have increasing values. And here we can say we have decreasing values, exactly opposite to what we saw in maxima, right? So let's say if I want to put it in a function form, how will we write it? Like if I want to express it in intervals, how do we write it? Okay, so let's write it in interval form. We can say that for c minus delta less than x less than c, that means all the values of x which are lower than c up to c minus delta, it should act as a decreasing function. Okay. So it should act as a decreasing function. It should come down, right? And then what can we say about the right side? So how do we express the right side? It will be c less than c less than x less than c plus delta. So in this interval of c minus delta to c plus delta, half part of it should be a decreasing function and the remaining half should become a increasing function. Then we can say that the point C is yes, we can say that the point C is a increasing point C is the minima. Okay, so I'll write that over here. Therefore, f of x has its minima or the minimum point at C. Okay, so this is how we can use the decreasing and increasing functions that we studied previously. Okay, now how do we understand or how do we find out these maxima and minima points? Okay, so for doing this, okay, so the next part is to methods to or tests to find out the maxima and minima of a particular function. Okay, so I'll do that in the next session. If you have any doubts regarding increasing, decreasing functions and what do we understand by minima and maxima, you can write to me. I'll explain it again in a different way. Okay, thank you so much.